3.3 systems of inequalities is really a continuation of 2.8. So you got to make sure you know how to graph linear inequalities. So there were, again, if you remember, 4 things, really 5 things that we have to look at and that you need to know. So I'm going to go over those 4 things again, and then we're going to go right to some problems in Delta Math. So if I have a greater than symbol or a less than symbol, I'm going to use a solid line. Okay, so we graph the line just like we would if it was an equation, knowing the slope and y-intercept. If I have a greater than or less than symbol, I use a dotted line. If I have a greater than or equal to, I'm going to shade above the line. And again, if it's a vertical line, then we would shade to the right of it. But I don't like to say the word right just because the lines, if they're really steep, can confuse us. So we always go above or below. And if it's a less than or equal to, we're going to shade below the line. Okay. Now, the one other thing we have to remember is when getting y by itself, if we divide by a negative, then we have to flip the inequality. Okay, so when getting y by itself, if we multiply or divide by a negative, we flip the inequality symbol. So as we're doing these problems, we have to keep that in mind because, again, when I'm graphing a line that looks like this, okay, this is my y-intercept, and this right here is my slope, which is rise over run. Okay, so the one difference between 2.8 and 3.3 is our solution set is now not just one shaded region. We've got to find where the intersecting shaded regions are, and I want to show you a few problems in Delta Math that you're going to have on your homework. So you're going to be given a couple of problems that look like this. They're already going to be in slope-intercept form. So we have to, again, graph the line. So you've got to be able to look at this first line, and you've got to be able to ask yourself, is it going to be a solid line? Is it going to be a dotted line? And am I going to shade above it or below it? So when I graph the first line right here, okay, I've got a y-intercept of 7, a slope of up 1, right 4. So it graphs the line for me. Now it says change the line, meaning if I click on that, it's going to make it dotted. Well, is my top line solid or dotted? It's solid because it's a less than or equal to. And now it says change shade. Do I shade above or below? I shade below. So there's the first line graphed. Then it will let me go to the second line with a y-intercept of -4, okay, and a slope of -5 over 2. So -5 over 2, I can go down 1, 2, 3, 4, 5, right 2. I could also have gone up 1, 2, 3, 4, 5, and left 2, and that would have gotten me to the same exact point. Now, do I need to change the line? Yes, because it's just a less than symbol, so it needs to be dotted. And then I'm going to shade everything below. So you have to make sure you're paying attention. It's a less than, so it's going to be below. When I click on this, it shows the green, and then my intersecting portion is this section right here, okay? So as I have this problem, if I were doing this problem on a piece of paper, my shaded region would be everything in, I messed up there. My shaded region would be everything in this area right here. Okay, so now Desmos is asking you to give me one point that is in this shaded region. You could choose any point you want. I'm going to choose this point right here, which is -4, 0. And again, when you submit it, it's going to tell you whether or not you're correct, and it'll give you a little explanation. And notice it's going to give you a different point than the one that you put. Okay, so let's go ahead and look at one more problem like this. Okay, making sure you know how to graph. What would my y-intercept be here? 3. So I go up to 3, plot it. My slope is up 1, right 5. Graph that, change the line to a dotted because it's just a greater than, and I want to shade everything above it. Okay, this one is greater than or equal to with a y-intercept at -1. I go down 1, 2, 3, right 5. Okay, and then it's going to be everything above. I don't need to change the line because it's supposed to be solid. I'm going to shade everything above, so it's where they both intersect. So you can tell the darkest region here is in this section up here. It's not this green area and it's not this light purple. It's everything up here. So again, you can put in any ordered pair. I'm going to put in the ordered pair 3, 5, just to show that you know that's where the solution is. Okay, so there's going to be 5 of these on your homework. You should definitely be able to do those problems. I want to look at a couple of these. So context inequality systems graphically. These problems I think can be a little bit challenging because we have to be able to set them up. Okay, so I'm going to go through this problem with you, and then I'm going to go down to the graph. So as I'm doing this problem, make sure that you're writing stuff down, because once I click a button, it's going to disappear. So you can pause the screen or whatnot. But again, with any of these problems, I have to let X equal something and I have to let Y equal something. Okay. So it says Owen and his children went to a restaurant where they sell hot dogs for $4 each and tacos for $2.50. Owen has $60 to spend and must buy a minimum of 18 hot dogs and tacos altogether. If X represents the number of hot dogs purchased and Y represents the number of tacos, so right there I'm told X is the number of hot dogs. Okay, and Y is the number of tacos. So again, I'm going to have a money equation here. Okay, so if Owen has $60 to spend, he cannot spend 60. He has to spend 60 or less. So I'm going to have one equation, which is 4x plus 250y, and that's going to be less than or equal to $60. Again, the number of hot dogs and tacos, when I buy them, I can't pay more than $60 if all I have is $60 in my account. And then the second equation says he must buy a minimum of 18 hot dogs. So I would have the number of hot dogs and tacos has to be greater than or equal to 18. Make sure you're paying attention to your symbol and this makes sense. Okay, again, this is the number of hot dogs plus the number of tacos, and I have to have a minimum of 18. So it has to be greater than or equal to. Now, here's the problem with how Delta Math does it. I have to set each one of these equal to Y to be able to graph it. Okay, so I'm going to subtract the 4x for this problem. Gives me 2.50y is less than or equal to a negative 4x plus 60. I'm going to divide everything by 2.5. Okay, make sure you have a calculator handy. I did not divide by a negative, so this is going to stay y is less than or equal to, okay, negative 4 divided by 2.5 is equal to negative 1.6, but I want that to be written as a fraction, okay? So make sure that you change that in a fraction. Again, if you're using Desmos, then you can just click the button over there on the left, and I want it to be my rise over run, so it's negative 8 over 5 x plus 60 divided by 2.5 is equal to 24, okay? So for this line right here, I would go up to 24, and then I would go down 8, right 5. Make sure you're paying attention to your scale that's on there. So again, as you're doing these problems, make sure that you're graphing them correctly, okay? And then my second problem, a little bit easier to solve for y. I'm going to subtract the x, and I'm going to have y is greater than or equal to negative x plus 18. Okay, again, pay attention to your symbols here. So I'm writing this down on a piece of paper, so I'm going to graph both of these to show you how the solution is and how to do this. Okay, so I've got my two equations. My first equation was y is less than or equal to, so I have to change this symbol. Okay, and then I'm going to put in a negative 8 over 5 x plus 24. Now, the nice thing is once you, I don't think that was right, plus 24. Okay, once I click plot, it graphs it for you, so you don't have to worry about that. But now you got to know the shade, okay? That's a less than or equal to, so it's shading everything below. The second equation was y is greater than or equal to, so don't need to change that, a negative x plus 18. Okay, so again, you plot that, but because it's greater than or equal to, we need to make sure that it's being shaded above that line. And now, where's your solution set? It's everything in between here. Okay, so again, you can put in Owen could buy any set that's in this shaded region right here. I'm just going to put 218, but you could put many different things here that's in that shaded region. Okay, again, that the tough part of graphing this is you have to put it into slope intercept form. Okay, they all have to be in slope intercept form. So there's going to be one problem like this one where you actually have 3 lines to set up. So in this word problem, again, you're still going to have an x and a y. So as we're going through this problem, kind of bear with me here as we do it. But says Scarlett has x dimes and y quarters, having no less than 16 coins worth at most $3 combined. At most, 22 of the coins are dimes and no more than 4 of the coins are quarters. Okay, solve this system of inequalities graphically and determine one possible solution. So now we have 3 inequalities in this problem. So I have letting x equal, so let x equal the number of what? Dimes, right? And let y equal the number of quarters. So I've got to be able to set up 3 different equations, okay? I'm going to set up a money equation first. We should know how much a dime is worth. So it'd be 0.1x plus 0.25y. And it says they have at most $3, which means this is less than or equal to 3. Okay? So that took care of this $3 combined. Okay? My next equation says having no less than 16 coins, which means x plus y is less than or equal to 16. Okay, at most 22 of the coins are dimes and no more than 4 of the coins are quarters. So for this equation right here, I'm going to have at most 22 of the coins are dimes. So I let dimes equal x. At most means what? There's no more than 22, so it has to be less than or equal to 22. And no more than 4 of the coins are quarters. So y has to be greater than or equal to, less than or equal to 4. Okay, y has to be less than or equal to, so this is less than or equal to 4. Okay, so this one actually gives me 4 different inequalities. I'm going to go ahead and plot these ones right here. Okay, so again, how do I plot these? I have to get the y or the x by itself. So for this first equation up here, I've got 0.1x plus 0.25y is less than or equal to 3. We've got to solve this for y. So that's going to be the biggest kind of point here, is making sure you solve this for y. Okay, so minus 0.1x, 0.25y is less than or equal to 0.1x plus 3. Minus 0.1. I'm going to divide by 0.25. Make sure you're paying attention to your decimals, and y is less than or equal to negative 0.1 divided by 0.25 is equal to negative 0.4, which is negative 2 over 5. So I have a negative 2 over 5 here. Okay, so negative 2 over 5. Come on, work for me now. No, it's not going to work now. Okay, so I'm going to have a negative 2 over 5 x plus, so y is less than or equal to negative 2 over 5x, and then I've got 3 divided by 0.25, and that's equal to 12, so plus 12. So I'm going to go here and I'm going to graph that line. Okay, and then I've got x plus y is less than, again, having no less than 16 coins. Okay, I wrote that sign wrong. That should be a greater than or equal to. This should be a greater than or equal to, because no less means you have more than that. So x plus y is greater than or equal to 16. So I would have minus x, y is greater than or equal to negative x plus 16. So again, when you're putting these lines in here, okay, you're going to have y is less than or equal to negative 2 over 5, and it does it for you, but you just have to make sure that you put these in correct and you solve for y correctly and all your signs are correct. Okay, plus 12. Okay, so now you've got y is greater than or equal to, I'll plot that, and it's less than or equal to, we're going to shade below. So this one, y is greater than or equal to, right here, y is greater than or equal to, and you have a negative x plus 16. Again, plot that. It's greater than, so I want to shade above it. So right now, this is my possible solution set. And then again, I had two separate lines here where it gave me 4. At most, 22 of the coins are dimes, and no more than 4 of the coins are quarters. So at most, 22 of the coins are dimes would be at most x, because we let dimes equal x. So x has to be less than or equal to 22. Okay, and that would be plotting that and shade everything to the left. Okay, so again, and actually, oh, there we go. There's my fourth line. So I had to add a fourth line because I had the quarters as well, and it said no more than 4 of the coins are quarters. So that would be y is less than or equal to 4. Again, you plot that, that's going to give me a horizontal line, and I need to shade everything below that. So it gets kind of messy as you plot these, but right here is my possible answer. So again, when it comes to dimes and quarters, anything in this darkened, really dark shaded region would work. And again, I could ask the question, like, how come nothing works here? And that's because that would be more dimes than 22. Okay. How come nothing over here works? Because that is not greater than 16 coins. So that it shows me why this is the only solution set right there. So Scarlet could have how many dimes? Let's just say 18. Okay, and have how many quarters? 2. That would be this ordered pair right here. Okay, we submit our answer. Okay, and it says it's wrong. Now, why is this wrong? Did I screw up a sign somewhere? And it's okay. You can make mistakes. So my 12 minus 2 over 5x was fine. Okay, at most 22 times my dimes. This one was fine. This one was fine. Okay. What did I put? What did I put as an answer? Your inequality x less than 22 is shade. Oops, I just hit the shade the wrong way. Less than or equal to, should have been everything over. So it's still this solution set right here. I accidentally screwed up one of the graphs, okay, by not clicking the button. So again, I wanted to show you making a mistake can happen. Just make sure you understand the math. All of my inequalities were right, but I made a technology error, and Delta Math is going to mark that wrong. So make sure that you understand that 18.2, what we put in there, is correct. Okay, but I accidentally screwed up this x is less than or equal to 22. I accidentally shaded it to the right because it can get very confusing when you're entering those into the calculator. Less than or equal to needs to shade to the left. So there's going to be a few problems like this. Do your best. I'm most important and concerned with you being able to set up all of the inequalities.